When Pluto was reclassified as a dwarf planet in 2006, many believed its story had ended. Once celebrated as the ninth planet of our solar system, it suddenly became little more than a distant frozen object drifting in darkness beyond Neptune. Cold. Silent. Lifeless. That was the assumption. But modern discoveries are rewriting Pluto's identity in astonishing ways. New observations from the James Webb Space Telescope and data gathered by New Horizons have revealed that Pluto is anything but dead. Beneath its icy surface may lie one of the greatest mysteries in the solar system, a hidden ocean that could change how humanity thinks about life beyond Earth. At the center of this mystery is Pluto's most famous feature, Sputnik Planitia, the giant heart-shaped region stretching across its surface. This enormous basin is made primarily of frozen nitrogen ice, yet it behaves unlike anything scientists expected to find on such a distant world. The glacier appears to move slowly across the surface, reshaping itself over time. Its sheer size even affects Pluto's rotation and gravitational balance, almost as if the dwarf planet carries extra weight on one side. But what lies beneath that frozen heart may be even more extraordinary. Scientists believe a vast subsurface ocean could exist deep below Pluto's icy crust. Despite being billions of kilometers from the Sun, internal heat generated by radioactive decay inside Pluto's rocky core may keep water in liquid form beneath the surface. That possibility changes everything. For decades, Pluto was viewed as a frozen relic from the birth of the solar system. Now it appears more like a dynamic world hiding energy, motion, and perhaps even chemistry capable of supporting life. On Earth, wherever liquid water exists, life often follows. Could the same be true on Pluto? The idea no longer seems impossible. Evidence gathered during the New Horizons flyby in 2015 revealed fault lines, deep fractures, ridges, and shifting ice fields spread across Pluto's surface. These are not features expected on a completely dead world. They suggest internal activity still reshapes the dwarf planet today. Even more intriguing is Pluto's unusual relationship with its largest moon, Charon. Unlike most planet-moon systems, Pluto and Charon orbit around a shared point in space located between them. Their gravitational interaction creates tidal forces that may generate additional heat inside Pluto's interior. Some scientists suspect these tidal effects help prevent the hidden ocean from freezing solid. And if a liquid ocean exists, another question naturally follows: could something be living there? Deep beneath kilometers of ice, shielded from sunlight and extreme radiation, microbial organisms could theoretically survive in environments radically different from anything on Earth's surface. Such life would not rely on sunlight, forests, or oceans under blue skies. Instead, it might thrive in darkness, pressure, and chemical energy hidden far below the ice. The discovery of even the simplest alien microbes on Pluto would transform biology forever. It would mean life is not rare or fragile, but capable of emerging in places humanity once considered impossible. Yet Pluto's mysteries do not stop there. The James Webb Space Telescope has also detected unusual chemical signatures and complex organic molecules surrounding the dwarf planet. Pluto possesses a surprisingly active atmosphere made mostly of nitrogen, mixed with methane and carbon monoxide. Sunlight interacting with these gases creates reddish compounds called tholins, organic molecules thought to be important ingredients in prebiotic chemistry. These hazy reddish particles drift through Pluto's atmosphere like frozen smoke, giving the distant world an eerie glow. What scientists once dismissed as an icy wasteland now appears strangely alive with chemistry, movement, and unanswered questions. And this may only be the beginning of Pluto's story. Far beyond the orbit of Neptune lies the mysterious region known as the Kuiper belt, a vast collection of frozen worlds left over from the formation of the solar system. Most objects there are believed to be cold, inactive remnants. But Pluto refuses to fit that picture. Its glaciers move. Its atmosphere changes with the seasons. Its icy crust appears fractured and active. And beneath everything may exist an ocean hidden in darkness for billions of years. Scientists now believe Pluto formed during the violent early history of the solar system, when countless collisions generated enormous internal heat. Some of that heat may still remain trapped inside the dwarf planet today, slowly escaping through its icy layers. This hidden warmth could explain why Pluto remains geologically active despite its incredible distance from the Sun. Its connection with Charon deepens the mystery further. Charon itself shows enormous canyons, deep grooves, and evidence of ancient tectonic activity. Strange reddish deposits cover parts of its poles, possibly created when gases escaping Pluto drift through space and freeze onto Charon's surface. The two worlds appear linked together in ways scientists still do not fully understand. Some researchers even speculate that Pluto could possess a weak magnetic field buried beneath its surface. While no direct proof exists yet, certain unusual heat patterns and geological structures have led scientists to consider the possibility. If such a magnetic field exists, it might help shield Pluto's atmosphere and hidden ocean from harmful radiation. That protection could increase the chances of long-term chemical stability beneath the ice. As technology improves, Pluto is rapidly becoming one of the most important targets for future exploration. The brief flyby of New Horizons lasted only a few hours, yet it completely transformed humanity's understanding of the distant world. Scientists now hope future missions could orbit Pluto permanently, map its underground ocean, analyze its atmosphere in greater detail, and perhaps one day drill through the frozen crust itself. What they might discover remains unknown. Perhaps only sterile water and ancient ice. Or perhaps a hidden ecosystem unlike anything humanity has ever imagined. Pluto challenges more than astronomy. It challenges our assumptions about where life can exist and how active small worlds can remain across billions of years. For generations, people saw Pluto as a lonely frozen object at the edge of the solar system. Now it appears to be something far more extraordinary, a world still evolving in the darkness. A world with hidden oceans, strange chemistry, shifting glaciers, and mysteries buried beneath ice older than human civilization itself. And somewhere beneath that frozen surface, Pluto may still be guarding secrets capable of changing science forever.